Hello, everyone, and welcome to today's One Key Idea session on defect detection effectiveness. I'm Rex Black, president of RBCS. We are a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, we've delivered insight and confidence to hundreds of clients around the world. We have a team of international consultants that deliver customized training, consulting, and expert services to companies that are looking to improve their test and quality assurance practices. If you have any questions during the course of the webinar, you may submit them throughout the presentation via your webinar interface, but please note that they are answered only at the end. And another quick note here, I have my webcam turned on, trying an experiment with that on these webinars, but due to the vicissitudes of Citrix software, when I look at the audience view, I don't see me. I see the slide, but I don't see me. So I have no idea whether you guys are actually able to see my smiling face and my fancy RBCS polo shirt here right now. But let me know if you are or not seeing that, because I'd be curious to know whether the webcam is indeed actually working. Oh, you do see me. Okay, great. Thanks, Lena. Oh, yeah, okay. Yep, everybody says they can see me. Okay, good. So it's probably a good thing that I remember to take a shower and comb my hair and wear my fancy RBCS shirt. Okay, so on with the show. We're going to talk about a deceptively simple but really powerful concept today, a metric called defect detection effectiveness. Pedro says, we cannot smell you. But good point, but I did shower, just trust me on that one. That's why my hair looks like it does, as opposed to sticking up every which way. So anyway, defect detection effectiveness, or DDE. It is, as the name implies, a metric of effectiveness rather than a metric of efficiency. Hopefully you're clear on the distinction that I'm making there. If not, that's going to be the topic of a future One Key Idea presentation, of the important difference between effectiveness and efficiency. But it is measuring how effectively we detect defects. And so the basic calculation is as shown here. You look at the number of defects that were found during the testing phase, and then you divide that by the number of defects found during the testing phase by the number of defects plus the number of defects subsequently found in production or post that testing phase. For those of you listening on the webinar version of this webinar, I hope that makes sense. Again, to recap, it's defects found in testing divided by the total of defects found in testing plus the defects found post-testing, basically in production. So pretty straightforward little metric there, but it has a number of really interesting wrinkles that can be applied here, and it should be kept in mind. So one of the ways to use this metric is to compare the DDE for all defects found against the DDE for defects of only severity 1. So basically you filter the defects in such a way that we look at the overall defect detection effectiveness, that's DDE all, and then the defect detection effectiveness for high severity defects only, that's DDE 1. And what you want is DDE 1 to be greater than DDE all. And I would hope that the reasoning behind that is obvious, that you want to be focused on the most important things, right? Finding the higher severity defects. Interestingly, when I've done this exercise as a consultant as part of doing a test assessment for organizations, that's not always true. Sometimes the DDE for DDE 1 is equal to DDE all. Sometimes DDE 1 is less than DDE all, especially in organizations that aren't doing proper risk-based testing. So this is something that you do want to look at. Now, another thing that you can do with this is to look at defect detection effectiveness with respect to a series of test phases. So, for example, you might hey, say you have a system integration test phase that happens, and then the software gets put into a staging environment, and there's a UAT phase, and then subsequently it goes into production. So what you would really want to do is look at the DDE of system integration testing, the DDE of UAT, and compare those two. So what you would want to see, to calculate DDE of system integration test, you not only look at the number of defects found in system integration testing, you also look at the number of defects found in UAT. So basically, you take the number of defects found in system integration testing and divide that by the number of defects found in system integration test, the number of defects found in UAT, and the number of defects found in production. The idea of adding the defects found in UAT to the denominator of that fraction is that basically your objective in system integration test is to catch those defects before they slip out, right? Slip it out into UAT. So let's say that you find 80 defects in system integration test and UAT finds 10 defects, and then there are 10 defects that are subsequently found in production. So your DDE is going to be 80 divided by 80 plus 10 plus 10. So in other words, 80%. Now the DDE for UAT is going to be 10 divided by 10 plus 10. They're only going to found 50%. So that's actually going to be a pretty poor number for UAT, and you'd want to look at ways of improving it. You'd also want to look at ways of improving your own DDE, because 80% is a little bit below average. When we do assessments for clients, we typically find an independent testing operation will find about 85%. Now, this is industry specific. If you're talking about say medical devices and so forth, regulated clients, when I go in and look at them, they'll have DDEs that score in the 99% range, sometimes a little above, sometimes a little below. Usually I say like 85% is average, 90% is good, 95% is very good, 99% is excellent. Now you might say, well, how about 100%? Well, yeah, in the long run, nobody gets that. Even the most stringent testing operations, like what NASA does, where they spend a year in testing before they send software up to the International Space Station, they will still every now and then miss a defect. So I always tell people, you can get 90%, you can get 99%, you get 99.9%, you can stack as many nines after that decimal point as you want, as long as you're willing to continue to throw money at it, and as long as you accept that you'll never actually get to 100%. Now, one of the things I should mention here too is some of you may not have heard of DDE, but you may well have heard of its inverse, which is defect leakage. Defect leakage is basically 100% minus DDE. And some of our clients that have outsourced testing service providers, defect leakage is the metric that they use as opposed to DDE, but it's basically the same thing. You could say that defect leakage equals 100% minus DDE. Okay, so that's what I wanted to say about that. It's like a very simple type of metric, one that is actually surprisingly underutilized, but is certainly by no means unusual. But would encourage you to start measuring it and start using it as a way of increasing your defect detection effectiveness. Now, of course, all of the caveats that are associated with metrics apply here. So if you're not familiar with those caveats, I would encourage you to go give a listen to my recorded webinar or the keynote speech version of it, Stupid Metrics Tricks and How to Avoid Them. There's actually a couple recordings of that. There's one that I did at PNSQC a couple of years ago, and there's one that I did in Moscow at the shoot, what's the name of that conference? That name escapes me, but anyway, I did it in Moscow too. That's a Moscow version, is somewhat shorter. The PNSQC version, I do a run through the famous Deming red bead, black bead experiment at the beginning of that. If you've never seen the red bead, black bead experiment, you might want to give that one a listen. But if you're looking for really short, the recorded webinar version, I think, is like 45 minutes. So take your pick. So I'll put the advertisement up here and open it up to Q&A. And let's see. So I got a question here from Tom, who says, after he put this up right after, or put the question up right after I posted the equation and explained it, he said, that makes sense. Is this a common equation used in the industry? Answer is yes. Not as much as I'd like to see. I'd like to see everybody using it. But certainly, yeah, it is commonly known. And again, organizations that sell testing services, basically testing service providers, will typically have defect leakage be part of their KPIs. It's very common to see that as part of the KPIs and contracts and so forth. So, you know, that's definitely very widespread there. Organizations that develop software for sale and organizations that develop software for their own internal use don't always use this as much as I would recommend. So I think if you're not using it, it's definitely one to look at. Tom's got a follow-up here. He says, what other metrics would you suggest we use to verify testing effectiveness? Oh, well, let's see. How about coverage? Some of you may have heard my presentation on dimensions of test coverage, where I talk about all the different ways of measuring test coverage. And, you know, hint, it's not just requirements or use cases or user stories or whatever name requirements go under in your particular organization. You know, there are also things like support configurations, user personas, roles. There can be all sorts of different dimensions of test coverage, and to be an effective testing organization, you want to make sure that you have you've addressed those areas. Really, what you want to do, though, I'm kind of going about this metrics question asked backwards, Tom. What you want to do is start with your objectives, right? Okay, what am I trying to accomplish in testing? And so then you go, okay, these are my objectives. So then you say, well, what would it mean to be effective at each of these objectives? And then from that point, you can start talking about how you could measure your effectiveness. And this is just the goal question metric technique. I believe it was Victor Basili that came up with that. So you've got a goal, I would call an objective. And you say, okay, what are some questions that we can ask about it, like how effective are we, how efficient are we? And then you develop your metrics from that. So don't let the metrics drive the objectives, do it the other way around. DDE is almost going to be a universal objective or metric for testing organizations, because just about every organization has defect detection as part of its objective, at least every testing organization. All right, I've got a question here from Lena? It looks like an I, but I think it's a lowercase l maybe. So she asks, how do you measure DDE in a Scrum type development cycle when defects are tasked until the product work item is complete during the sprint? Okay, yeah, I had an email question in advance too that's kind of similar to this, which was, you know, what if my company was told not to track bugs found during sprints? Well, the short version is, if that's the case and you want to track DDE, you're hosed. Okay, sorry, it's just you have to have some way of measuring the defects that are found in a testing phase and subsequently in order to carry out that calculation. And I've had this conversation with quite a few clients over the last few years about, you know, somebody came in and gave them this brilliant idea of, oh, you'll be more efficient if you don't track bugs during your sprints. And so they stopped tracking bugs. And I'm like, well, guess what? You know, your car will also be more efficient if you disconnect the speedometer, because, I mean, the speedometer is basically sitting there sapping energy out of the drivetrain to spin a generator, I believe, and then you're measuring the amperage of that. I believe that's how a speedometer works, basically. So it is draining power out of your car, and so, gee, that's really wasteful. Um, well, yeah, but except that you really, really, really do need to go know how fast you're going, don't you? So it's worth it to set aside a little bit of the energy coming out of your motor to measure how fast you're going. And this is the same thing that I would say with capturing defects. And people say, well, it's going to be too much overhead. Oh, well, if it's too much overhead, then reduce the amount of overhead. Like one of my clients that I'm working with now just has gone to a very, very simple approach when they find defects during the sprints, whether these defects are found in user story refinement sessions or as part of doing test design or as part of executing their tests. They track them in a spreadsheet. I just make a spreadsheet notation. Okay, this, whoops, this happened. Oh, was it a defect? Yes, it was a defect. And now they're able to calculate defect detection effectiveness. They're also able to track all their defects from discovery through to resolution, which, people say, nah, you could do that with email. Really? You never lose anything with emails. That's not really the case. So, there are all sorts of reasons why that idea that I believe the people that I heard espousing it first were the Poppendieks. Apologies to them if I'm blaming them inappropriately, but they were the ones that I first heard espousing it on agile testing circuits, and I think that was an extremely ill-considered idea. If there is some activity that is giving you useful information, but it's requiring too much overhead, the cost of gathering that information is too high, you don't stop gathering the information. You figure out a more lightweight way to gather the information. So, and again, I think this is a very valuable piece of information. Okay, let's see. I think I've got another. Okay, I got a comment here from Scott. Rex, I like the webcam. It has a positive dimension of the webinar, but the map behind you is an odd angle. Yeah, I'm sitting at an angle to my desk behind the, and behind me is the wall, but how to describe this? This is like the office space is at the top of the building, and so what you're looking at there is the angle of the roof, right? Because that's the roof going up there. So, yeah, I agree that could be a little strange. Hopefully, it's just kind of more intriguing than distracting. Let's see. Another question that pops up frequently, which I will address here before we wind it up. Some people will say, well, I have a problem because our production defects are tracked in an incident tracking system like ServiceNow, and the testing defects are tracked in Jira or Rally or Bugzilla or whatever. So how am I going to do this? Well, it's not really a problem. You can have disparate data repositories as long as out of those two repositories, you can get the two numbers that you need to get. Now, the trick with incidents is that a lot of times not every incident is actually a defect. It's not triggered by a defect. It can be, somebody kicked a plug out of the wall, right? So you need to be able to make sure that you can filter the incidents down to those that actually turned out to be caused by defects. But assuming you can do that, no problem. So don't worry about, hey, I've got two different repositories. But one thing you do have to worry about if you're going to try to do that thing that I was talking about, that DDE1 versus DDE all comparison, you have to make sure that severity 1 means severity 1 to everyone. In other words, incidents don't get classified with a different severity classification than defects that were found during testing, or just even within production and or testing, are people inconsistent in the way that they use their severity classifications? Because that does happen, and if that's happening, then that DDE all versus DDE one comparison is not going to be as meaningful as it will appear. It's just, again, pretty much like anything else in metrics, is that if you have noise in your source data, you can have metrics that come out of that appear to be reasonable, but in fact are actually misleading. So do be careful of that. Okay, cool. Well, we're right on time, more or less 20 minutes. So I'll go ahead and wind this down. Thanks for showing up for webinar number 2 today. I hope you enjoyed this free webinar from RBCS. We do these free webinars as a service to the software testing community, because at RBCS, we are a not just for profit company. If you enjoy our free webinars and feel that they demonstrate solid insights into the kinds of testing challenges you face, please make RBCS your preferred software testing vendor for any and all expert services, consulting, or training. Happy to provide a quote for any such help you might need. Just contact us, info@rbcs-us.com. Again, thanks for attending, and I look forward to seeing you at an upcoming webinar in, say, April, or if you are at the SDP conference coming up in a couple weeks, look forward to seeing you there. Stop by the RBCS booth and say howdy. Thanks again. Bye for now.